This one again says write each expression as a single logarithm. So this is another way of saying simplify. You want to write everything as a single logarithm, but in these ones we have a couple of different laws at the same time. So can you see in part A that we have adding, and we also have a number out in front. So the question we have to figure out is, well, what do we do first? Do we apply the law that says adding first? And I'll write out these two laws. Here's your adding one from your formula sheet. And we also have a number in front, so I'll write that one out. Now, in order to use one of your laws, it has to match up perfectly. So some things that are here that need to match up. For the adding one, the bases need to be the same. Are our bases the same here? Okay, what are the bases in part A? The base is 10, because those are common logs. When it's not written, that base is 10. Okay? And the only way you can combine things is if you have a log plus a log. Do I have a log plus a log? No. I have a log plus a 3 log. I have a 3 in front, and that doesn't match the first formula. So I'm not allowed to use the first formula yet. Because the first formula only works if you have 1 log plus 1 log. And I have 1 log plus 3 logs. How do I get rid of that 3? That 3, I could take as a first step, I could put that 3 inside as an exponent and use this second log law that says if I have a number in front, that number can become an exponent. And now I have a single log plus a single log. And so now I can say these can be multiplied. And we've written it as a single log. Whew. Second one, we have 3 of them. Okay? We have a log plus a 2 log minus a 4 log. So I'm going to write also our other log law up here that says if you're subtracting 2 logs, then you can divide. Yes? Do I divide by just this one that's minus here, or? Well, the 2 log y is a plus right now. Okay. Good questions. You're wondering what to do with those numbers in front. Are there any numbers in front in the subtracting? No. So you can't use that if there's numbers in front. So one of the things you might notice already is the very first thing when you're trying to combine something as a single log is if you have any numbers in front, you're going to want to put them inside the log. So I'm going to start by log x plus log, what's that 2 going to do? Y squared minus, what's that 4 going to do? Z to the 4. Now at this point, you have a log plus a log. What could you do with that? You could combine those two by multiplying. And we would still have log z to the 4. And now we have a log minus a log, so we could write this as a single log that way. They're both going to be over. So Well, it's not, this is, you want to add another log on the bottom.
Yeah, like take out the Z4.
And write it like this.
Yeah.
Okay. So this can't happen because if we go back to our log law, and we're looking at this one here at the end, when we have subtracting, how many logs are on the left-hand side? Just the one log. The dividing happens inside of the log. So one of the things that we're sort of getting used to is just how do we apply these laws? How do they work? What things need to be in place in order for them to work? Now before we get to C, I'm going to add a B.5. Halfway between B and C. So in B.5, what you're going to do is you're going to combine log A minus log B plus log C minus log D, wow, plus 7 log E. Does that seem long? Okay. And we're going to do it in one step. So as a single log, it's going to be log. There's going to be a fraction here because we have some minuses. And in the end, whichever logs are positive, so that'll be our log A, our log C, and our 7 log E, those A, C, and E to the 7 will all appear in the top of your fraction, and B and D will be on the bottom. So when you have multiple logs and you're combining it as a single log, whichever ones are positive will end up in the numerator, whichever ones are negative will end up in the denominator. And can you see that we could have done B a lot quicker that way? Can you see that both the x and the y squared are positive, they end up in our numerator. And the z to the 4 is negative, it ends up in the denominator. Which is helpful because if you try to do it one at a time, you'll probably make a mistake with a negative somewhere along the line and then it runs into some problems. And then finally part C. Part C is difficult because there is no number or no log in one of them. We have log base 2 of 6 minus 3. Well, I could combine these if this was log base 2 of 6 minus log base 2 of something. But what number am I going to put right here? 8. Why 8? Because 2 to the power of 3 is 8. So log 2 of 8 is equal to 3. And then I can write this, because I'm subtracting, as log 2 of 6 divided by 8. You could reduce that to 3/4 if you like, or you could leave it like that. 5, 8, 11, and 18